Page 9, I believe, problem 16, and we want to find points of intersections of two lines. When you want to find points of intersections, you're basically trying to solve the equation for an x value and y value where they both cross, where they would intersect. So the way these two are set up, I'm going to take advantage of using simultaneous equations or using elimination, where I'm just going to stack the equations and see what I can get to cancel out. So I think what I'm going to do is I'm going to multiply the second equation by 3 and subtract them. So when I do that, I'll end up having, I'll just write the top equation, and the bottom will be 3x plus 15y plus 9. They're both equal to 0. But I'm going to said I was going to subtract them, so that disappears. I'm going to subtract this, I'll get negative 16y, and when I subtract this, I'll get negative 16. Oh, look at that. Love textbook math. 16y equals 16. Y's got to be negative 1. When I get that answer of y being negative 1, I can plug them into either equation. So I'll just use, I'll use the second one because it looks like it's going to be a little easier to work with. I have x plus 5y plus 3 equals 0. I'll plug in negative 1. And I'll end up getting x minus 5 plus 3 equals 0, or x equals 2. So my point for my intersection is 2, negative 1. Okay, folks, I've started this number 17 just because I didn't want to take up too much time, but basically we have two inequalities that we want to solve, and we want to shade the region for it. So the first equation, I label over here equation 1 after I put it into slope-intercept form. I found that its y-intercept was negative 7. That's what I have marked here. And its slope was 3, so I counted out a slope of 3, up 3 over 1 to find my next point, and drew a sketched dotted line. That should the dotted line is dotted because when I shade in, because it says it's less than 0, I'm going to shade below that line. So in blue, I'm going to shade under it. So I'm just going to do that to show that I'm underneath or less than that line. And on the next one, it says for equation 2, when I solve for that, I had a y-intercept of negative 3/5, so I tried to mark that on the x-axis, or on the y-axis, and I counted off a slope of 1/5, which meant of negative 1/5, which meant I went down 1 over 5, which kind of did that sort of adequate enough, I guess. And here I want to shade above in red because it's greater than or equal to that line, so I'm going to shade above. But because it's equal to, I've got to include that line, so I'm going to draw that as being solid. So now I've got a shade above that line. So the combined region of both, the intersection of these two areas, I'll shade in green, will be this area here. So that would be that graphical solution, or shaded region, the xy plane, representing where those two solution sets intersect. And that's the end of page 9, I believe. So be working on page 10. Okay. Good luck.